Okay, in this problem here we are told that the entrance to Mistletoe Farm, there's been a string of lights hung in the shape of parabola. So what we'll do is we'll just make a parabola. And it's hung, so it means it's hanging down. Then we're told that the entrance is 6 meters wide. So I'll just say the entrance, this is the door, or the entrance, so this is the door here. So we're told that this distance here is 6 meters. Okay, and that the lowest point of the lights is 4 meters above the ground. So if I draw an axis across here, so this is my x-axis and this is my y-axis, then this distance from the turning point to the ground, that's 4 meters. Okay, and I know that this is the midpoint, so therefore this distance is 3 meters and this distance is 3 meters. Okay, because that's halfway in between. Then I'm also told that at the height at each side of the entrance is 5.5 meters. So this distance from there to the base is 5.5 meters. Okay, and I haven't got the whole question here, but I guess you're trying to find the equation of that particular line. The way I would do this is, because we're dealing with whole numbers here, I would deal with what we call the vertex method. And that's where you map the vertex in terms of its distance from the origin. Okay? And the way you do that is you work its horizontal and then its vertical component. We know that the formula for that general point of the line is y equals k, and k is your scale factor, x plus b all squared plus c. Now the b, or the x plus b, this is the horizontal difference, this horizontal distance here. And we know that that's 3 meters because that's halfway. And it's to the positive, so we would say y equals k, x minus 3, because remember it's the opposite when it's in bracket, all squared. Now we have to work the vertical distance, that's 4 meters and it's gone up, so plus 4. Now what we need to do is work out what k is. K is like the scale factor. And to do that, we need to find a known point that is not the turning point from which we can substitute the values in. And I suggest you use this point here on the graph. It's quite easy. That particular point is at 0, 5.5. So at 0.5.5, what we're told here is that this first value is our x value. That's our x value, that's our y value. So we're going to substitute those values in. So if we substitute those into the formula, 5.5 equals k, 0 minus 3 all squared plus 4. So if we carry on doing the algebra here, we've got 5.5 equals, now 0 minus 3 all squared, so that's negative 3 all squared, is 9. So we've got 9k plus 4. So you can see how I got that. Then what we do is we move the 4 across to the other side. Okay, so we subtract 4 and we end up with 1.5 equals 9k. Now what we can do here, because we're dealing with a decimal, what I would do here, and you could leave it as it is, because you'd simply now go k is equal to 1.5 over 9. That's what that says there. But that's quite ugly, so I'd double that. What's double of 1.5? Well, that's 3, and double of 9 is 18, so that's actually the same as 3 over 18, which equals 1/6, and that is equal to your k value. So your equation, I'll just put it up here, because obviously you'd have more room in your books. You would have y equals 1/6 x minus 3 all squared plus 4. And at this point here, I would go to your graphics calculator and substitute or put that into your graph form and see if the points are all correct on there. Because we've got 3 known points here. We've got this first point here, which is at 0, 5.5. We've got the second point here, which is at 3, 4. And we've got this point over here, which is at 6, 5.5. And that should show up in your table of values.